So we have some.
Fluorinated gases. Oxygen.
I've heard carbon dioxide. I've heard oxygen. Anyone know? Is it just
O2. O2.
O2? Other gases? Missing like three. There's some nitrogen.
Avery and Polly and sorry.
Other gases there?
Fluorinated gases. I don't know what they said.
Fluorinated gases. Yeah, there's some like argon.
Water vapor.
Ah, nice. Good one. H2O. Funny, right? How about like relative amounts?
Mostly.
Let's take some votes. Who thinks it's mostly CO2? We'll do it like this. One, two, three. Maybe water vapor and maybe fluorinated gases. Vote now. Which one do you think is the most common? Carbon dioxide, oxygen, nitrogen, fluorinated gases. Or sorry, water vapor or fluorinated gases. Vote now. Which one's the most common? Most of the year. Is it mostly carbon dioxide? Mostly oxygen? Which was that? Mostly nitrogen? Vote three, mostly water vapor. I got a lot of threes. Some fours and twos. It is actually the percentages. 78%. That's crazy. These are good numbers to know. Write these numbers down. Yeah. Good numbers to know. Next most common. Oxygen is 21%. Cool. What's that leave us? 1%. That is 1%. Yeah, everything else in the atmosphere is 1%. What? And that includes CO2 here. Whoa, whoa, whoa. Mostly nitrogen, with quite a bit of oxygen too. Yeah, there's like some really trace amounts, and these percentages kind of dwindle further and further. Questions so far. If you drew a pie chart, maybe just sketch one right now. What would this look like as a pie chart? Doesn't have to be perfect, but sketch yourself a rough little pie chart. What would this look like? Insert drawing. You're doing it like you're doing on your notebook. Insert drawing in my notebook. So for a pie chart, I'm going to draw a circle. Then what am I going to do?
Split up the circle.
Yeah.
Yeah. Like 1%. Everything else.
So I could split it into 100 pieces. Yes. Other ideas? How could I do this? What did you do? How did you know like where to put the lines?
Huh?
Yes.
You got like from like 75 is like got a little bit more.
That's a great way to do it, right? So if you split it into 4, these are all 25%.
Leave a little less.
So you can just do like a little bit less than that, right? Do it like that. Great way to do it. Or you could split it up into 5s. That's 20% each.
Yeah.
But yeah, pretty much O2, N2 for nitrogen, and then a tiny sliver of everything else. The funny thing is that tiny sliver can have a huge impact on the rest of the systems. Okay.
Crazy.
Huh?
Crazy.
Okay, I'm going to erase. Yeah, good. I'm recording this too, so you can go back and rewatch. All right, now we're going to draw the layers of the atmosphere. Oh, so we're going to draw this sort of like on a graph. So our bottom axis here is going to be temperature. And we'll say in degrees Celsius. Ranging from 20 or so degrees Celsius, all the way down to negative 100 Celsius. Oh, this is going to be hard to draw, yeah.
I'll take a picture of mine.
Yeah.
This blue.
How about our y-axis? What's this going to be? We're looking at the layers of the atmosphere. Any guesses?
Altitude.
Yeah, exactly. Altitude. I'm going from sea level, right at the bottom, which, fun fact, sea level actually is not the same all over the world. It changes in different places. It's kind of funny. Also, it changes through time, obviously. And then going up to like 100 kilometers plus. Okay. So there's like 5 layers of the atmosphere or so that we're going to go through. Anyone know of any or know?
Ozone.
Sort of. It's part of one of the layers. It's ozone, yeah.
Atmospheric layer.
I'm going to give you guys an acronym. So this was actually an acronym that the senior class like 3 or 4 years came up with. The massacre starts today, starting from the top. So this is an acronym. Massacre starts today. And then there's I guess you could say ESS could be the first one. This is the very, very outer layer, which anyone know it's called, the very outside. Extraterrestrials come from the exosphere. Yeah. way to imply that. Basically, like you kind of like the ultimate reach of the Earth's atmosphere, gravitational pull. Okay, T. Let me see. You can see all of this. Oh no, there we go. Okay. So starting with the top T at the very, very edge, we have the thermosphere. Thermo meaning.
Temperature. I don't know.
Yeah, exactly.
Yeah.
Mhm. This is where it starts to get super, super, super hot. And then we got mesosphere.
Stratosphere.
Stratosphere comes next, yeah. That stratosphere is like really associated with atmosphere a lot. I think that guy that did the really high skydive or whatever, it was like, they were saying it was like the name of their operation or whatever, even though it's not the highest
Operation.
by a long shot. How about down here? That starts with a T. Yeah, something sphere. That's a great guess. Yep.
Yeah.
Oops. This will be the troposphere.
I was gonna say tropics, and then I was like, that sounds like rainforest. Like,
Hemisphere? Yeah, hemisphere means half sphere. Yeah. Cool. So in between each of these, you have like what they call different pauses, right? So there'd be like the tropopause, and then the stratopause, mesopause, etc. And so these are just like kind of layers that kind of separate, or like barriers that separate the layers. Yeah. Look at all that. And we're going to start at ground level, because that's where we live. That's what we know the best. What's the temperature like down here between 20 and negative 100? And are we closer to? Closer to over here? And they actually draw a little mountain in the book. Who's climbed to the top of a mountain before?
yeah.
As you climb a mountain, what happens to the temperature? Yep. Thanks. Cool. So the temperature decreases as you go up in altitude. Why? Because it's colder. But I thought hot air rises.
But it's less pressure.
Let's add another column over here. Low pressure. And I'm just going to put in quotes high pressure. Because, I mean, high relative to that, but like it's not that much pressure. If you go into the ocean, very, very high pressure down there, crush everything. If you want to use units, you could say it's 1 atmosphere down here. That's the pressure. It's actually the weight of the entire atmosphere above you. So who did scuba diving for field trips? Anyone? Did you guys learn about like atmospheres of pressure?
Absolutely.
Yeah, so when you're on Earth, right, we have like 100 kilometers of air that gives us that much weight. The same amount of water is like what? I think like 3 feet or something. Like an atmosphere, maybe it's 3 meters. Yeah, 9 feet. That sounds about right. Yeah, so every 9 feet you go down, it's like a whole nother atmosphere on top of you. Which is why you go down like 100 feet, it's already like a bunch of pressure. Yeah, and then you go even further, and it's like you go really far in the ocean, and it can like pop a cork into a wine bottle. Like so much pressure. Yeah, really wild. Okay, then we hit this tropopause, and then something funny is going to happen to the temperature. Any guesses? It's gonna what?
Increase.
Yeah, it actually goes the other way. Yeah.
What are they doing?
Oh, it's I don't really know exactly. It's like
It's okay. It's fine.
it's complicated. Yeah.
Like an eye.
I mean, there's like
The other way too? Again?
Huh?
Does it go back again?
it does. Yeah. So that's why we start from the bottom, because this is the most intuitive for us, right? And then once again in the thermosphere, this is where the name for thermosphere comes from. Right, it gets hotter and hotter and hotter to something like 1500 degrees Celsius.
In our thermos.
Yeah. Yeah.
Great.
Isn't space cold enough?
It depends on if you're in the sun or not, basically. It's like where all the heat's coming from. And so like once you leave the atmosphere, you don't have anything reflecting any of that heat. So it's just all like hitting you. Yeah. So if you're like in the shade, it would be super cold. But if you're in sunlight, way hotter. Kind of a funny issue. I mean, like here on Earth, we experience temperature by existing in the gas. And the temperature of the gas is just how often they're hitting each other. If it's a high temperature, it's like a mosh pit and they're hitting each other a bunch. If it's a low temperature, it's like a classical music concert with social distancing and everyone's really far apart. They're plowing through all of that air, yeah. And all the air like gets compressed basically. And it's like chemistry law, right? As you compress a gas, it gets warmer. There's actually a what if where they look at if you could try to cook a steak by dropping it through the atmosphere. Just like I think it would like sear the outside a little bit, but that's it. Yeah, interesting. Okay. Oh, I want to add one more thing in here. What we could add? Huh? Yeah.
I was just wondering what those two red birds to the left. I don't know if it's like no doubt. But yeah, what are those?
Sea level.
Yeah.
Yeah.
And what about the 100?
Negative 100 degrees Celsius. Yeah. Burr, 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 burr. This is where most of our weather's happening. And you see like these clouds and stuff.
Oh.
And then someone mentioned the ozone. Anyone know where that is? Each of these up in the sky somewhere.
Is there a top two?
Like, it's on the stratosphere.
Actually in the stratosphere, yeah. I kind of want to try to draw it to scale too, because that'll be really fun. Anyone know how big it is?
No.
Isn't it small?
It's like really small. Trying to scale just for funsies. The ozone layer is roughly like a few millimeters.
That's it?
Yeah, probably like that. I can't even draw it that small. Yeah, that's like actual size. So if you were to draw it to scale, it'd be like
So to scale, it'd be like the whole.
yeah, thin little line right there. Wild, right? We'll talk a lot about the ozone in depth, but anyone know why we care about it?
Yeah, it's important.
Yeah, a certain type of radiation specifically.
Ultraviolet. I don't know.
UV, yeah, it's really handy that I happen to have my purple pen. Protect us from the UV lights. I actually wrote UV this morning because we were talking about glacial valleys versus river valleys to make a U shape versus a V shape. Okay, we're going to transition to a couple of graphs here. So I'll pull the graphs up on the screen. And then if you want to look at them on your computer too, you can do that. But then there's just a few questions where you sort of analyze the graph. So this first one, we got historic changes in the atmosphere. So we're looking at how carbon dioxide and temperature are related in this graph.